Thank you for joining this lesson, viewers. Today we are going to discuss SADs. It's a topic that we are going to look into in three ways. Simplifying a SAD, rationalizing a SAD, and conjugate pairs. And so, maybe you can have your calculator so that we try to look at some of these values. Number one will be root of 36, square root of 36. And if you use your calculator, you get 6. Number two, root of 144, square root of 144. And that one, your calculator gives you 12. Number three, cube root of 8, cube root of 8, it's 2. What about fourth root of 16? You get 2. What about square root of 2? You get 1.41. And what about cube root of 21? And that gives you 2.76. Okay. That is going to form the basis of our study today, and probably SADs. So very first we move to laws of SADs, and our learning intention today will be to explain what a SAD is and to investigate the rules for SADs. On the other side, success criteria will be to learn rules for SADs and use rules to simplify SADs. Now, the first rule, which is square root of A, or what we call root of A times root of B. That will give us square root of AB. You multiply. So, let's see what this means in an example. When we have square root of 4 times square root of 6, we will get square root of 24. Another example, square root of 4 times square root of 10, we get square root of 40. So if you can list the numbers, if you can list the first 10 square numbers, maybe you take one up to write 1 to 10, and then you get their squares. What kind of values are you going to have? So we'll have 1, 4 all the way to 100. Of course, the square root, 1 square you get 1, 2 squares you get 4, 3 square 9. So you continue with the sequence up to 10 square you get 100. Okay, so we start with a very simple question of what is a SAD. Now, you recall that square root of 36 is 6, square root of 144 is 12, and now the above roots have exact values because we are not getting a fraction, we are not getting decimal, we are only getting whole number. And now we call these rational numbers. Okay, square root of 2, on the other hand, is 1.41. I think that is what we got in our previous, in the previous part. Cube root of 21 is 2.76. And now you realize that these answers are in decimals. These roots do not have exact values, and we call them irrational numbers or SADs. So that is the meaning of SAD. Numbers whose roots are not exact. Okay, adding or subtracting SADs. So this is on the addition and subtraction of SADs. And now we say that adding and subtracting a SAD such as root 2 or square root of 2 it can be treated in the same way as an x variable in an algebra. So, for example, we are going to take that the side as x, so that we have to find we have to make the addition and subtraction quite simpler. Okay, we are going to follow with the following example, so that to be able to illustrate at this point on the subtraction and addition of sides. So we have 4 root 2 plus 6 root 2, and now we will have it as 10 root 2. So you realize that side there, which is square root of 2, has been treated as x, so that when we have 4x plus 6x, you get 10x, but now our x in this case is square root of 2. So the answer will be 10 root 2, or 10 square root of 2. That is the side in this aspect. Example number 2, 16 square root of 23, or 16 root 23 minus 7 root 23 will get 9 root 23. We have just treated the side in this case, which is root 23, to be x. And now 16x minus 7x, you get 9x. And our x in this case is square root of 23. And now our answer is 9 root 23. Maybe we can look, we can go for our last example in this case, combining the addition and subtraction in one question. 10 root 3 plus 7 root 3 minus 4 root 3. The answer will be 13 root 3. It is just that simple, because we are treating the side in this case to be x. So you do the addition, subtraction, then you find the answer, and finally you now write the value of that x. Okay, so but then you need to note that root 2 plus root 3 does not equal to root 5. If you take square root of 2, square root of 2 plus square root of 3, that cannot be right to say it is 5. It is root 5. Simplifying square roots. Some square roots can be broken down into a mixture of integer values and sides. The following examples will illustrate this idea. And the first example is square root of 12. And now, to simplify square root of 12, we must split 12 into factors, with at least one being a square number. So this one is going to get us, the two factors in this case is 4 and 3. And we know very well that 4 is a square number, and so square root of 4 will give us 2. Now our resultant side in this case, the simplified side, is 2 root 3. 2 root 3, because square root of 4 is known to be 2. Okay, some other more examples. Root 45, rather square root of 45, we have to come up with two factors, with one of the factors being a square number. So in this case we have 9 and 5. So square root of 9 is 3, and square root of 5 is a third. So to simplify it more, then we shall have 3 root 5. Okay, on the other side, square root of 32. So the two factors in this case is 16 and 2. So we have to break down root 32. We'll have square root of 16 times square root of 2. But square root of 16 is 4. Now our simplified surd is 4 root 2. Now we have root 72, and as well we also think of the two factors. There can be two factors or more, and this one is going to give us square root of 4 times square root of 18. So square root of 4 is known and it is 2, and square root of 18 can be further simplified because it is a surd. Can be further simplified because 18 can be written in two factors, that is root 9 times root 2. So that means we have 2 times square root of 9 times square root of 2. And finally, of course, we know that square root of 9 is 3. Now, we have our simplified surd to be 6 square root of 2, or 6 root 2. Now, let's take assignment. We have quite a number of them. Number 1, square root of 20, and this one is 2 root 5. You think of the two factors, and one of the factors being a square number, so that you simplify it further. Number 2, root 27. If you do that very well, you will get 3 root 3. Root 48, it is 4 root 3. So my appeal to you is that first do the assignment, so that later on you get to check with the answers that have been provided in this case. Okay, now let's now move to laws of surds, the second law of surd. So our learning aim here is to explain how to rationalize a fractional surd, and our success criteria. Know that root a times root a is equal to a. That is what will form the basis of our second law of surd. And now we will be able to rationalize the numerator or denominator of a fractional surd. Now the second rule, square root of a times square root of a. You'll get a in that case. And now some few examples on this to illustrate more. So we have square root of 4 times square root of 4 is equal to 4. And because of course we are looking at the rule and we are trying to prove that rule. So that is example number 1. Example number 2, square root of 13 times square root of 13. It is 13, because now you will probably get square root of 169, and square root of 169, it is 13. So that is what our rule is all about. Rationalizing surds. Now you may recall from your fraction work that the top line of a fraction is the numerator, and the bottom line of the same fraction is the denominator. And now this can be illustrated below. 2 over 3 as an example. 2 is on the numerator, 3 is on the denominator. Now fraction can contain surds, and this can be shown as below. Square root of 2, or root 2 over 3. That is a fractional surd. 5, another example is 5 over 4 root 7. Another fractional surd. 3 root 2 over root 3 minus root 5. Another fractional surd. And now we want to look at a situation whereby we are simplifying a fractional surd by what is called rationalizing the denominator. If by using certain math technique we remove the surd from either the top or bottom of the fraction, then we say we are rationalizing the denominator or we are rationalizing the numerator. So we shall see this in our example below, and we carry on with our rule, that is the square root of a times square root of a, it is a. It will give us a. So this will help us to rationalize a third fraction. And our first example here is 3 over root 5. 3 over root 5. And for us to be able to rationalize this, then we say that to rationalize the denominator, multiply the top and bottom of the fraction by the square root you are trying to remove. The square root we are trying to remove in this case is root 5, square root of 5, which is a third. And so we are going to multiply the fraction by root 5 on its numerator and the denominator. And so we have 3 over root 5 times root 5 on the numerator over times root 5 on its denominator. And so that will get us, of course, we use our rule which says that square root of a times square root of a, you definitely get a. Now in this case we have square root of 5 times square root of 5, it will be square root of 25, which will give you 5. And now to finalize on this, it will be the numerator will get us 3 root 5 over the denominator is 5. And that is our simplified third, and it is rationalized. The denominator has been rationalized, and you can see it is not a third. The denominator is not a third. Okay, another example, number 2, 3 over 2 root 7. We do the same because we are multiplying either we are multiplying the top or bottom, or rather the numerator and denominator, by the root we are trying to remove in this particular case. So we have 3 over 2 root 7 times root 7, because root 7 is what we are trying to remove here, times again root 7 on its denominator, and therefore on the numerator side we will get 3 root 7, and on the denominator we have the rule which says root of a times root of a, the answer is a. And now here you find out that root 7 times root 7, it is root 49, square root of 49, and probably that is 7. And so it is 2 times 7. And therefore on the numerator we have 3 root 7 over 14. That is our answer in that case. Now let's take some few assignment before we move to our third rule. We are going to rationalize the denominator in each of the following case. Now we have 7 over root 3. If you do that very well, you get 7 root 3 over 3. Number 2, 4 over root 6. The same way, you'll get 2 root 6 over 3. And you continue with that assignment. Of course, you do the assignment first, and then you get to check the answers later. Now, the answers for the other questions is also provided. So it is you to do the work first, and then you check there. Now, laws of thirds. I think this is now our last law on this topic, and it is on conjugate pairs, the conjugate pairs. Now, we are going to explain how to use the conjugate pair to rationalize a complex fractional third. On the other side, on success criteria, we should know that root of a times root of b bracket, and then open another bracket, root of a minus root of b is equal to a minus b. That seems to be a difference of 2 squares, because just from its nature, it is a difference of 2 squares, which exist in that format, a plus b, a minus b. Now, we'll be able to use the conjugate pair to rationalize complex fractional surd. Therefore, our third rule, whereby square root of a plus square root of b, then another square root of a minus square root of b is a minus b. The difference actually is in the signs. And now some few examples. Number 1, we have root of 7 plus root of 3, then root of 7 minus root of 3. Actually, you see here, we are just trying to substitute in the rule or in the law. Now, this one will be 7 minus 3, because in our question, a is represented by 7 and b is 3. Now, we said it is a minus b, so our a is 7 and b is 3. Now, the answer will be 4. Yeah, you can also try to expand it. Use the expansion method. You will just get to the same answer, which is 4. So these are a bit more shorter towards simplifying this. Now, number 2, root 11 plus root 5. Another one, root 11 minus root 5. So they sound to be the same, but it's only the signs. Now, the answer there is 11 minus 5, and that probably gives us a 6. Now, look at the expression. The expression here is root 5 plus 2, then root 5 minus 2. So, these are conjugate pair, of course. The brackets are identical apart from the sign in each bracket. And now it looks something to be a difference of 2 squares. And now we can, by multiplying out the brackets, we'll be able to get, of course, in this case we are trying to expand. We are not really multiplying it with the, whereby we say a minus b, but also if you also use that, you'll probably get to the same answer. But now we want to try a different approach, whereby we expand. And so, when we take root of 5 plus 2, root of 5 minus 2, and then try to expand it, then of course we'll get a 5 times root 5 times root 5 minus 2 root 5 plus 2 root 5 minus 4. If you know expansion very well, it is just the same thing. It's just the same thing. So it will get us 5 minus 4. So it is proving our law, and in this case it is law number 2, law number 3. And so our answer in this case will be 1. It's the same way you take a, of course it is a difference of 2 squares is a minus b square. So of course you are going to get the square root of root 5, you get 5, and then the square of 2, you will get 4, and then that one is 1. Now, the brackets are multiplied out, the surd, and end up seeing that the expression is no root, have got no root sign. Okay, some other more examples before we have our assignment. 2 over root 5 minus 1. So we'll do the same. In this case, we'll multiply by the conjugate. The conjugate, of course, the surd is in the denominator. The surd is in the denominator. we are talking about the conjugate pair. Conjugate pair is a situation whereby when we have root of 5 minus 1, then its conjugate pair will be root of 5 plus 1. Because we said initially as we started that about law number 3, it is root of A plus root of B, then root of A minus root of B. And so that is what we are trying to do here, because that is the conjugate pair that we are working with. Now, in this case, denominator, we multiply both the denominator and the numerator by the conjugate pair to the surd given in the denominator. So we have root of 5 minus 1. So it will be, the conjugate pair will be the fraction, which is 2 over root 5 minus 1 times denominator times numerator root 5 plus 1, because that is the conjugate pair, and over root 5 plus 1 on the denominator. Root 5 plus 1 on the denominator. So you multiply both top and bottom. So that one will get us, you now at this point just work out the numerator separately and denominator separately. Then you will have that 2 into bracket root 5 plus 1, because you will have to open that. And then on the denominator, you realize that it is a difference of 2 squares. Difference of 2 squares, whereby it will be a minus b square. Now, so we'll get on the numerator 2 into root 5 plus 1 over 5 minus 1, because it is square root of 5 square. So you get that to be 5, then 1 square, you get what? You get 1. So that answer will give us, we have now 2 root 5 plus 2, and then over 4. Then now you simplify further. Your final answer will be root 5 plus 1 over 2. So you be very keen there, because now you see we have 2 into root 5 plus 1, which now you have to open. You need to open the bracket, what we call you expand. You open the bracket. And so after doing that, then you will be able to work out the denominator, which will give you 4. After that, you now simplify, because now you'll find that there are some terms which can cancel each other. And therefore, our last example, 7 over root 3 minus root 2. So in this case, we just do the same. We multiply by the conjugate pair of the side in the denominator. And so our fraction remains the same as 7 over root 3 minus root 2 times the conjugate pair. That will be root 3 in the numerator, root 3 plus root 2. You see now the difference is in the signs. And so times denominator the same, root 3 plus root 2. And now solve the numerator separately and as well the denominator. So we shall have 7 into root 3 plus root 2 over 1 in that case. And probably that gives us the answer. 7 into bracket root 3 plus root 2. Now, let's now have some assignment. Number 1, rationalize the denominator in the expression below. So we'll be able to go through that and find the answer. Number 1, number 2, all the answers are provided, but as well, like I say, you need to first do the question so that you finish up with the answer later. You check with the answer later.